Yes. No, sir. We cannot see the slide. I can see the slide. So where are you now? Are you in Microsoft Teams?
Yes, you are all in Microsoft Teams. I think
Ah,
you should share the screen, sir.
I already share. What do I have to put open in SharePoint? Do I have to open in SharePoint? Hello? Hello?
I'm not sure, not sure, sir.
So,
Maybe you should try it.
okay, can you see now? Share, yeah, I already share. Can you see now? Hello? Hello?
Still no, sir.
Then you have to upload yourself. No? I can see ready. So I already uploaded. Can you see now? Hello? Can you see the slide? Hello? Can you see the slide now? Muhammad Aiman. Who is that? What about now? Now? Can you see the slide now? Hello? Muhammad Aiman. I already uploaded. Yeah.
No, sir, we can. But just now we can, but it suddenly disappeared again.
Yeah, it will come. Which one you are seeing? Euler method, Yoon's method, fourth order Rangi-Kutta method.
We can see your screen just now, but I'm not sure which slide that you open.
No, today we do fourth order Rangi-Kutta method. So what you do, you go to ulearn, take out the slides. Can you open ulearn? Open the fourth order Rangi-Kutta method. Hello? Hello? Okay, can you see the slide now?
Can.
Can you see the slide now?
Can.
Huh?
Yes, sir.
Can
Yes.
see
Yes,
already.
can. We can see the slide now.
How to make it bigger? Huh? Because it is too small.
Read mode, sir.
Huh? Which one? How to make it bigger? I cannot move the slide.
Beside the percentage, click the icon.
Where?
The top bar.
Uh-huh.
Beside the percentage, you can see, right, the squarish thing.
How you move the slide now? I cannot move the slide. It stuck. Yeah, Wong Chen. Okay, you can see the slide. Okay. Okay. Can you see the slide? Fourth order Rangikota. Yeah.
Now hilang.
Okay. Now can you see it? Hello?
No, sir.
Uh-huh.
We cannot see now.
Okay, what you can do, you go to ULearn, take the slide out, 4.3. Open up. Go to ULearn, open up the slide, 4.3. Can you open up 4.3? Hello? Hello? Class, can you open up 4.3?
Wait, sir. We are doing.
Yeah. Today we do 4.3. Yeah, because I cannot upload. I tried to share, but it's not coming actually. My file is. Okay, class, can you see the slide 4.3? We.
Yes.
Huh?
Yes, we can saw the slide.
Okay.
3.4 order runge kuta method.
Yes. There you are. Okay. All right. Start recording, huh? Okay. So we already finished Euler method. We already finished Yoon's method. Today, fourth order Runge-Kutta method. Okay. So slide number 4. So 4.3 is fourth order Runge-Kutta method. RUNGEKUTTA method. So you can pronounce Runge Kota or Ranch Kota. So the learning outcome is, at the end of this section, you should be able to solve the IVP, initial value problem for ODE, by using fourth order Range Kota. First order, second order, third order, we don't do it here. This is already done, improvement. Later you will see how this is connected to somehow to Euler method. So the name is fourth order Runge-Kutta method. Is a new method, very important for the engineering student, because we want to solve the differential equation, especially the first order differential equation. So Runge-Kutta or Ranch-Kutta is the name of the two person. The short form is RK. Yeah? Remember, yeah, RK. So Runge-Kutta methods achieve the accuracy of a Taylor series approach without requiring the calculation of higher derivative. This is the keyword. Yeah. So it does not require higher derivative. It just using the iteration method and then using the differential equation dy dx as fxy. You will see later on the formula. The formula is a little bit lengthier, but since you have a calculator, so you can use the calculator to the maximum and then solve the problem. So various type of Runge-Kutta methods can be devised by employing different numbers of terms in the increment function of specified by n. This n is what we are referring here as the order, nth order. So they're giving you some the background that first order Runge-Kutta method with n equals to 1 is in fact Euler's method. So it goes back to the original Euler's method, first order, then develop second order, third order. Now we are in the fourth order. So the second order, third order is, we are not going to do anything here. It's already available in the literature. If you want, you can refer to any numerical analysis books. So we are focusing on the fourth order only, fourth order Runge-Kutta method only. So we no need to go back to the Runge-Kutta first order, second order, third order. We just focus on fourth order. So what is important here, class? This one you got to do a lot of numerical calculation. We call it as a numerical experiment. So the most popular Runge-Kutta method is the classical fourth order. Fourth order. I highlight, yeah. The pen is not working, so I highlight. Can you see the pen? Can you see? I put.
Can, sir.
I highlight in pink color.
Yeah, we can see pink color.
Pink color, you can see, huh?
Yeah, I can see.
This one, I put
yes.
on circle like that.
Yeah, I can see.
Okay, now the pen is working, lah. Thank God. Okay,
Alright.
so the most popular Runge-Kutta is very interesting, class. If you really pay attention, it will be very interesting. Runge-Kutta method, because this method is very good for the solving basically engineering problem. So the formula goes like this. The formula goes like this. Actually, the formula is this one. Yeah. Y xi plus 1 equals to yxi h over 6 k1 plus 2k2 plus 2k3 plus k4. You need not memorize this. Just be familiarized only. Need not memorize this. So this formula, for you to just no need to memorize. Just take note only. We want to use this formula somehow or other and try to understand what this formula is all about. Okay. So you see the K1, K2, K3. That is the important thing now. The K1, K2, K3. K1, the K1, K2, K3 is defined like this. This one. So K1, K2, K3. First, you have to find K1 first. So how they define K1 is very easy. K1 equals to Fxi, Yi. In the calculation, you don't put the subscript Xi, Yi. This one, Yxi plus 1, actually is the output. This is your output class. This is your input. This is the initial condition. This is the one you are going to calculate using these formulas. K1 defined as Fxi, Yi. You no need to memorize this, but you must familiarize first. So the K1 here goes inside here. But the K2 also goes inside here. But before that, the K1 is inside here. That is very important now. Okay, this K1 goes inside here. This K1 Fxi, Yi. And K2 is f of xi plus half h, yi plus half K1h. So the K1 must go inside. And this is the output y. And the yi now become yi plus half K1h. Now the K2, goes inside here. This is your K2. And finally, when you calculate K3, f xi plus half h, yi plus half K2h. And then you calculate K4. When you calculate K4, K3 goes inside here. This is Fxi plus h, yi plus K3h. So you have K1, K2, K3. All this goes inside here. That is Runge-Kutta method. So take note, yeah, it will be a time-consuming work. Time-consuming work because the whole thing here, goes inside this part. This part. But h is given, yxi is given. Now you want to find this output. This output is the one you want to find. So what is the meaning of this equation, class? This is the previous output. This is the current output, the new output. The xi is the old input. Xi plus 1 is the new output, input. Xi plus 1 is the new input. Xi is the old input. Y xi plus 1 is the current output. Yxi is the old output. So now, of course, the theory here is not very much. Theory not very much. The important thing is the formula. And then straight away, the theory is not much. You just have to know this equation. Just have to know this equation. You have to know this equation. That's all. So this equation is sufficient for you to use this equation. And then the K1, K2, K3. So in order to explain this, since not much theory behind it, we straight away solve problem. That's why engineers, they like this method because it solves the problem. So the problem is dy dx. This is the problem, yeah? Our problem is dy dx. This is our problem. This dy dx, you already solved in chapter 1. You may ask why you want to solve again. That is the whole idea. The motivation about this method is we want to use numerical method. This gives a kind of a boosting power to solve some very difficult problem which cannot be solved by the chapter 1, such as separable, integrating factor, linear, Bernoulli, exact, non-exact. Cannot be used that precise method, including Laplace. First order, Laplace can be used. Mainly we use Laplace to solve second order, but first order linear constant coefficient, we can use Laplace. But why Runge-Kutta? Runge-Kutta is approximated method or approximation method to solve the differential equation. Take note here, use fourth order Runge-Kutta. So you cannot use any other method. So when they say fourth order, the word is fourth order. So you cannot use Euler method. You cannot use Yoon's method or any other method. But in this topic, chapter 4, we limit ourselves up to 3 methods, very famous 3 methods. All are very interconnected. Euler, Yoon's, but Runge-Kutta is already very far from Euler and Yoon's method because it's a fourth order. So we call this as a very advanced method. Now, the reason why we don't want to use Euler, Yoon's here, because we want to get more accurate. Accuracy is one of the important factor in solving the differential equation. So we want to solve this problem, dy dx equals to x multiply y over 1 plus x squared. Actually, this is separable equation, class. This is separable equation. But we want to solve using numerical method. So the information which is very important here is use fourth order. Okay, we already knew what is fourth order. The equation yxi plus 1 yxi h over 6. You cannot change that. H over 6 all you cannot change. That is already fixed. K1, K2, 2K3, K4. So the important thing here is, what is important is this method, RK method. Okay, no problem. RK method. But more importantly, you want to calculate the y at x equals to 1.1. And take note here, at x equals to 1.1, given, this is very important, given y1 equals to 1. That means when x equals to 1, x equals to 1, x equals to 1, then your y is equals to 1. This is called initial condition, class. So if you put a straight line, this fella is x is starts from 1. This is what we call x naught. Normally they don't write. I don't know why, but it's important. X naught means is initial condition. X naught. This is x naught. This is y naught. So start from x naught, y naught 1. H is 0.1. This one is x1. This is the whole study is about this. Calculate x1. Where? At x1.1. This one. x1 1.1. What is your y1? That's all. Y1 is what? This is what this question all about. You can draw this picture. H is this one. This is your H. This is H. How to calculate? 1.1 minus 1. This length is H. This length is H. This given already, but still you can find from here also. This x1 is 1 plus 0.1. Make sure you understand this. It's easy, but you will confuse later on. Yeah. Whether given, not given. That is the challenge. If not given, we will face big problem. So you have to read the question carefully. So at x naught, your y naught output known already. This is y naught is 1. So this is known. But at x1, 1.1, y1, we don't know. If I add one more, then this become a homework for you. x2. This one is x2. x2 is 1.2. You can put 1.2 and then look for y2. This is a challenging part. So like this, you have to do quite number of iteration. The word iteration is missing in the slide. You can write down iteration, So if I start with x naught 1, y naught 1, I can find my y1 at x1, 1.1. Input given, find output. At x2, 1.2, what is my output, y2? At x 1.3, what is my y3? What is my new output? So like this, you are searching for new and current output. This is very important, class. This is very important because for known input output, you are finding the unknown input output. Unknown output, basically unknown output, because input is known. What is input? X naught is 1. This must be given. If this one not given, cannot solve. Cannot solve. H is the additional information. But if because they ask you to estimate y, this word estimation is very suitable for this Runge-Kutta method because this is all about estimation. Estimate at x 1.1. So you are looking for the output when x1 1.1. What is my y1? And this one x2. What is my y2? This is additional work. You can take it as you can do it at home. But now we have to find y1 first. So there are many issues will arise. Many issues will arise while you are doing this. Let us see now the calculation. Formula is clear. Okay, formula is clear. You must use this formula. Formula is clear. So you keep on writing this so that you don't forget this. Formula is there already. K1 fxi yi. I repeat again. K2 fxi plus half h yi plus half k1h. K3 fxi plus half h yi plus half k2h. K4 fxi plus h yi k3h. You must be familiar with this. But if you refer to another reference book, they may have slightly different style. But Runge-Kutta fourth order is fixed. You cannot change. Runge-Kutta fourth order is like this. But the style of writing, they can change it. That one you have to refer to other reference book. But if you stick to this note, it is sufficient enough. So it is sufficient enough. You just stick to this one. So it is sufficient. But if you stick to other formula, Runge-Kutta, there must be some difference, slightly. But end of the day, if you use fourth order Runge-Kutta different style, but it is fourth order Runge-Kutta, output must be the same. Output cannot be different because the problem same. So the output input is the same. So output must be the same. But different method, different output. That means this problem, if you solve by Euler method, of course, the output is different. Same problem, output different. And then we become comparative studies. Euler method, good or not? Yoon's method, good or not? Runge-Kutta method is good or not. Then it is very thorough analysis, more detail. Okay, now our problem is we want to solve this example. We give you a simple example for you to familiarize first, because this involves quite a lot of calculation, yeah, numerical experiment. Yeah, if you make slight mistake in K1, your K2 will go wrong. So this is very serious. If you make mistake in K2, your K3 will go wrong. If K3 wrong, K4 wrong. Therefore, your output Y will be wrong. So all are interconnected. Therefore, we have to double check. So later on, you can skip some of the step. Now, this is just like a crawling stage. So we show you A, B, C until Z, everything. But later on, you can cut short. Later on, you can cut short. So what is step 1? If you have any question, you can stop me, class. If any question, you have to stop me orally, because you cannot write anything here. So if you have question, you can stop me anytime. Who is NZ? NZ, are you there? NZ? Najmuddin, yeah? Najmuddin? Are you there, Najmuddin?
Yes, sir.
Okay, so far okay?
So
Any
far,
problem?
okay, sir.
Okay, all right, thank you. So the dy dx, xy 1 plus x squared is your fxy. So they forgot to write. This is your fxy. This one is your fxy. Write down, yeah. F, actually x subscript I, but they don't write the I there. And that is the problem now. Yi. I just write here for your information. So dy dx is your fx I yi. So we say fxy. Because this is differential equation, we transform into a numerical method. So we don't write dy dx here. So the k1 is fxi yi. So if you want to calculate the k1 is fxi yi. So x naught, y naught, write down, yeah? X naught, y naught is 0, 1, 1. X naught is 1, y naught is 1. How do we know? From the problem. Go back to the problem again. So if you're not sure, go back here. This one. This one meaning y naught 1. So this one is very important. Now it is very important. Y1, 1. So from here, you get this F11. Pay attention, yeah? To calculate K1, you follow this K1, follow this formula. So this is your K1, right? So use this formula, K1, and then substitute. So your job is just plug the value, 1, 1. F11, you must use this one. This is your F11. So F11, you must calculate using this formula. What is the meaning? X1, Y1, starting. This is what we call initial value condition or initial value problem, but the condition is initial value, or we call it initial condition. So F11, X1, Y1. So substitute, see what happens. X1, Y1, 1 plus x squared. So you just have to calculate x1, y1, 1 multiply 1, 1. 1 plus 1 squared, 1. So this one equals to 1 over 2. Okay. So 1 over equals to 1 over 2. So 1 over 2, we don't write 1 over 2, we write 0.5. You must use os decimal point, yeah. And remember, yeah, Rangi Kota, very rare we use fraction because it will go up to 5 decimal point or maximum 6 decimal point. We don't want more than 6. Minimum 4, maximum 6, average 5. So K1, 0.5. Now, you want to calculate K2 now. So K2, this formula. So straight away, you have to go back to this formula. This is your K2. Fxi plus Fh, yi plus F K1h. But before we find K2, we must calculate this first. This calculation is important. Xi plus Fh, yi plus F K1h. But later on, you can do on your own, no problem. So they show you. This is your dy dx. This is your fxy class. Please remember, yeah. This is your fxy. This one you cannot change. Keep on writing fxy. So your K2 is, this is the formula. So this K2, you must calculate this xi plus Fh first. And then yi plus F K1h next. That is the problem now. But you can use your calculator. You can calculate very fast. So xi plus Fh. Xi is the x naught. That's why I told you they forgot to write the x naught. But they know this is the original x, initial condition. So x naught is 1 plus F 0.5. H is 0.1. So this is very important. So your H is 0.1, multiply 0.5 plus 1, you get 1.05. This is the new x. And the new y, yi plus F K1h. So y naught is 1, F 0.5, K1 0.5, you already found. The K1, you take it from here. K1 0.5, H is 0.1. So now you calculate, use your calculator, take out your calculator, and then you calculate, you get 1.025. This one maximum 3 digit. So it's okay. Because sometimes we cannot get more than 3 digits because it stops there. Now, you want to calculate K2. So we proceed to K2. K2 equals to F xi plus Fh, yi plus F K1h. So xi plus Fh is 1.05. Yi plus F K1h 1.025. From where? From the previous, this slide. Slide number 10. So your new y is 1.025. Your new x is 1.05. You put this inside this equation. This equation you have to put inside here. X is 1.05. The calculation goes like this. Calculation goes like this. X 1.05 from where? From this equation. Yeah. So you take this equation, put it here. 1.05 x, y 1.025, divide by 1 plus x 1.05 squared. So you simplify this, you get 0.51189. So this is your K2. So your K2 is 0.51189. Now, K3. You see, they write the formula for K3 every time. This is very important class. Every time you must write this formula. K3 equals to F xi plus Fh yi plus F K2h. So this part is the same, but they still redo again the whole thing. This one redo again. X naught plus half h. X naught is 1, half 0.5, h 0.1. You get 1.05. Now, yi half k to h, this is the problem. This one, y naught is 1. 1 over 2, 0.5. But K2 is this value. From where? From the previous slide. 0.51189. Multiply by H, 0.1. You get new Y. This is the new Y. We have to plug inside here to get the FXIYI. So, K3, this is to calculate K3. X is 1.05. Y is X is 1.05. Y is 1.02559. You take this, put inside here. Again, repeat. This is how the Rangikuta works. So X 1.05, Y 1.02559 divided by 1 plus X squared, 1.05 squared. You can test now. Use your calculator now, all of you. Get the answer 0.51219. I wait for you. Yeah, can you get this answer? Hello? Anyone there? Got this answer? 0.51219. Hello, class. Could you please verify this answer? Hello? Could you verify this answer? 0.51219. Yes, class. Hello?
Yes, sir, same, sir.
I'm waiting for you. Who is this? MS. I cannot see your name. So you got this answer? 0.51219.
Yes, sir, same.
Mohammed Dennis, yeah. Mohammed Dennis.
Yeah, I got the same answer like this.
Okay. Okay, good. Thank you. Now K4. K4, totally different. K4, the formula is F xi plus h, yi plus k3h. So this is your fxy. Fxy. So the new x, so you are calculating the new x, xi plus h. So xi plus h, 1 plus 0.1 equals to 1.1. This is your new x, this x. And new y, yi plus k3h, yi1, k3, 0.51219. This one 5 decimal places. From the previous slide, you already obtained k3 and h is 0.1. Now you take your calculator, calculate the whole thing. You should be able to get 1.05122. So this is the answer, K3, K4. Sorry, not yet. YI K3H 1.05122. And now we want to calculate the K4. So K4, the calculation goes like this. F xi plus h yi K3H, xi plus h 1.1. From where? From here, 1.1. And your yi plus K3H, you already knew, 1.05122. Now the calculation is using this formula. Using this formula, you have to calculate x is 1.1. This is x. This is your y, 1.05122. 1 plus 1.1 squared. So you should be able to get 0.52323. Can you verify this, please? Anybody can verify this? Can you verify K4? 0.52323, 5 decimal places. This is your K4.
Yes, the same.
Oh, thank you. Who is that?
Dennis.
Thank you, Dennis. Thank you.
Sir,
Okay. Yes. Yeah.
So
Uh,
how many decimal place do we need to take for each value of K?
Yes, this is a good question. So, depend on your calculator, and we don't want more than 6 if possible. But it was not mentioned in the question, how many decimal places. In the question, it was not mentioned. So it's up to you. But we don't want less than 4.
Okay, sir.
Four,
Thank
four
you.
decimal places up to 6 decimal places, because this is time consuming. If you round up, make it 5 decimal places.
Okay, sir. Thank you.
All right, welcome. Now we want to calculate your new y now. That is the biggest challenge now. So your K1, K2, K3, K4 all already found. So we already have K1, K1 0.5. You must write down K2 0.51189. You calculate by yourself. Yeah? K3 0.51219 and K4 0.52323. Now the final part. The final part is you have all these K1, K2, K3, K4. Now you use the formula xi plus 1. What is the meaning, class? This is your next y, next output using this formula. So before you use this formula, your K1, K2, K3, K4 all must be ready. You may ask, can I do it one shot? Put everything inside. It's up to you. But remember, your output y at 1.1, as I said before, you start from y at x equals to 1 with h 0.1. The next output is 1.1. This one, sorry. So 1.1 is the output at x 1.1. So equals to y1. y1 0.1 divided by 6. You cannot change that. In the bracket 0.5, 2 multiplied by K2, and this is your K2, plus 2 multiplied by K3, plus K4. So you simplify using your calculator now. Use your calculator. Can you get this answer? 1.1.05119. This is your answer. 1.05119. This is your output at 1.1.
Yes, sir. It is somewhat the same.
Same.
It is same. Yeah,
Very-
just round off to 5 decimal point. Yes, it's
Okay.
exactly the same.
Okay, okay, good. All right. So now the y at 1.1. So you already answered the question. But the problem here is we are not sure the value at 1.1 output is the final output. So you just calculated the y at x 1.1. This one. So we go little bit further. This 1.1 x 1.1. So you found your y. So you can make a table now. Your homework, yeah. You no need to do now. Two column only. So x, y, first row, second row, x naught 1, y naught 1. 1, 2. Third row, x 1.1, your y is 1.05119. Now, because we don't know this answer correct or not. Correct in sense that where it goes to like a steady state, where it stops. Now we don't have a stopping criteria. There will be a stopping criteria. Maybe they ask you to do another 2 more iteration, or they may say the difference between the y output iteration 5 multiply iteration 4 should be this much. That is what we call the error. But in this case, we suggest you, not now, yeah, later, when you're free, you can try x at 1.2, 1.3, and 1.4. This is your homework. 1.1 is you already knew. The 1.1, the answer is already known. So this is the answer at 1.1. Now at 1.2, 1.2 we don't know. And then 1.3 we don't know. And then 1.4, enough. If you do this, if you do 3 more iteration, then you will know this answer is stable or not. Because by just doing 1 iteration, we call this as insufficient class. Insufficient. But that doesn't mean that this question is not good or good. This example is, nothing much you can learn on the stability or the convergence. That is actually further studies. But this example just to show you the first iteration. Now you can do for the second iteration, same thing. Your xi plus 1 here will be 1.2. This will be y xi is 1.1. So this y1 at x 1.1, the y is 1.05119, this value. This value is your y 1.1. So this 1.1 will go here, the next one, this one. And then your K1, K2, K3, K4, you have to calculate again. But H remain the same. Because your K1, K2, K3 is depend on the formula. So your K1 is F x1 y1. So x1 1.1, y1 1.05119. So that one we haven't calculated yet. This one F not yet. F 1.1. F 1.1. The next one. So this one F 1.1, and then this one Y1 1.05119. Then you put inside here, you calculate K1. And then for K2, you put inside the K1, but the XI is different now. So this is your X1, 1.1. So this follower will be 1.1. And the Y1 is 1.05119. All will change. So you will make up the table for this example. And this example, just to show you how to calculate 1.1. But the next example, we will show you the real table. But here you can see the table now. I want to explain to you. This is the table which I told you. You got to create this table. This table, you see here, 1.1, they haven't completed yet. You have to complete this at home. Go home, fill up this. This one, 1.2. Write down here, 1.2. This one, 1.3. And then this one, last one, 1.4. This is your homework class. Wonderful exercise. Now, this one, first iteration, x1, y1, this one is given. This one given. You calculated K1 0.5, K2 0.51189, K3 0.51219, K4 0.52323. You already calculated. And then you plug inside yxi plus 1. This is the value, you got it. This value output at x equals to 1.1. But this one, not yet. This one is for x 1.2. It works like this. This one, this whole thing is to calculate your y1, this one. Now, this one, you have to fill up to calculate the y 1.2. Here, write down 1.2. So this one, you have to fill up. I put the question mark. So this one, not yet. This is the question mark. So after you fill up, you already found K1, K2, K3, K4 for X 1.1, 1.05119. You calculate your new Y at 1.2. And then you fill up all this. After you fill up this and then this, you calculate your Y at 1.3. And then you fill up this and calculate all this once done, and then calculate 1.4. So at 1.4, you may find this value only. This one is up to you. But it will, if you leave it empty, it does not look nice. So you have to fill up this all. 1, 2, 3, 4. You have to fill up. So you complete the whole table. That is your exercise. So we already done for you the first iteration. This is called iteration number 1. This is iteration 2, 3, 4, and this one is 5. But you may say, why I want to calculate this one for 1.5. But since the table it is constructed in this way, so we fill up this. I will show you example in the next slide how this table is completed. Any question, class? Yeah. Any question? so far? Example 1. Chia, yeah, Chia. Chia Cheng Hui, yeah. Any question, Chia?
So far no, sir. So far no question.
Okay. Others, please. Others?
So
Yes.
does that mean the 1.05119 is the final answer, or should we complete the table to know the final answer?
No. This one is just like a motivation. This result often displayed in a table just to give you the rough idea. This one we call it just like table form, because this table form is completed one. But in this problem, just we want to show you the method for one iteration only. So this iteration only. So the second iteration, third, fourth, fifth, we didn't show. So according to the problem, it's already solved. Table not necessary, but they say the best way to display or to present the output is in the table form. This is very good for Rangikuta method because we can check where you made mistake. So we have the answer. If your K1 is incorrect, but K2, K3, K4 correct, we know your Y is slightly there is an error. So this is a good presentation. For presentation, this is the best way. But for answering the question, as you asked, this is the answer already. So we put this table to encourage you to do another 3 more iteration or 4 more iteration. But as you know, as far as the problem concerned, it's already solved. Problem already solved. This is the answer. You can stop here already. So this is the answer. So you already got 10 over 10 for this problem. But the idea of this method is not only this one, no, it's more than that. We want to investigate what happened, these values. From the problem, they just ask you find the output at x 1.1. So this one is over already. But we want to know what is this thing, how the behavior of the output after number of iterations. Then you can say something about the output, the characteristic or the behavior of the output. But at the moment, we cannot say anything. So this is just an exercise only. But if they want you to complete the table, then the problem will be changed. They will ask you to do from x1 to 1.4. Then this table will be fully completed. Any more question, class? Any more question, class? Hello? Any more questions? Mohammed Irfan, yeah.
No, sir. Thank you.
No more. Okay. Okay. All right. So we move on to the last example for today. Example 2. Look at the example 2. Again, fourth order Runge-Kutta method to solve this differential equation. If you look at this differential equation, dy dx must be left hand side. Yeah. This is your fxy equals to yx squared minus 1.1 y. So it's look like Bernoulli. Dy dx pxy equals to qxy power n. So doesn't matter whether Bernoulli, linear or separable, we want to use the fourth order Runge-Kutta method. From x0 to 2 with h 0.5. So this one you must know that the x starts from 0 like this. This one is 0. Then this one is 2. 2. So 0.5. So this is 1. This is 0.5. You got to put like this. Otherwise, you may miss the point. What is happening here? And this is 1.5. Write down, yeah? So they want you to find, solve dy dx from x0 to x2. H must be 0.5 and y naught is 1. So when x0, your y naught is 1. When x 0.5, you don't know your y1. 1, we do not know. This is y naught, y1, y2, y3 also we don't know. The last one is y4. So using this value, y naught is 1, we have to predict, we have to estimate what is our y at x 0.5. That is the first iteration. Using fourth order Runge-Kutta method. Other methods is not allowed. And then find y at x1. After 0.5, what is 0.5? That is an input. So what is the output at x equals 0.5? Yet to be found. When x equals to 1, what is your y? When x 1.5, what is y? When x is 2, what is your y? So that is the question, class. So the answer is already given in the table form. The reason why they didn't show you, because it will take a very long time to calculate. So I just explained to you how they got this table. And you can verify this later using your own calculator. Because you saw just now the table was empty in the first example. But now the table is full. So if you don't believe, you have to verify, validate, and test this output. So this is the complete form for the question. This is the complete form. So you see the x from 0, and then 0.5, 1, 1.5, and 2. So these are the output. You can see the output 0.6, drop 0.4, decrease and increase, and then increase. From 1, decrease, decrease, and then slight increase, but below than 1, but later increase. So it looks like parabola shape. Parabola shape. The output is like parabola. So why I say parabola? Because it goes from 1 to 0 0.6, 4.6, and then go up 5.9, and then 1.58. So now, what is the meaning? X0, Y1. You can see here, X0, Y1. This is X0, X0, Y1. This is X0, Y1. So straight away, you create the table. The calculation K1, K2, K3, you can do the what we call in the rough paper. You you scribble. You can just scribble only. The K1, K2, K3, K4, all these value class, you can find using the formula, this one. So if you do now, it will take time, but just I give you an explanation. The K1 will be minus 1.1, K2 minus 0.75219, K3 minus 0.8424, K4 minus 0.49198. You may wonder why there is a discrepancies in the decimal numbers. So as I said, since there is no any rules mentioned in the question about number of decimal places, so they take for 5 decimal places, 4 up to 5 or maximum 6. So once you have a K1, K2, K3, you calculate your Y for X equals to 0.5. Because the H is 0.5. In this case, the table is necessary because we have to complete until X equals to 2. So when X 0.5, your Y is 0.60157. Use this value to calculate your K1 minus 0.51133 minus 0.25463 minus 0.28913 minus 0.0457. Use this value, calculate your Y. And this will be at X equals to 1. Automatically at X equals to 1, you get Y 0.46452. And use this X and Y 0.46452, calculate K1, K2, K3, K4. So your K1 will be minus 0.04645, K2 will be 0.20947, K3 will be 0.239062, K4 will be 0.671663. So using K1, K2, K3, K4, you predict your Y. When X is 1.5, answer is 0.59138. So use this X 1.5, Y 0.59138. Go back to the previous formula K1, you will find 0.68008. K2, 1.49425. K3, 1.893701. K4, 4.460869. Now, you use K1, K2, K3, K4, and then your X 1.5, Y 0.59138. You calculate your Y. This Y will be at X equals to 2. So, answering the question, you already answered. This one, 1.5844, is the answer from 0 to 2. But if you leave this thing empty, this one does not look nice. So you use X2, Y 0.58445. you calculate K1, K2, K3, K4. Get ready for X 2.5. No need to write 2.5, just letting you know if they want you to find what is the value at X 2.5, you must have this value. So it's just like getting prepared before you ask to do so. So at X 2.5, you can use the K1, K2, K3, K4. 4.59491, K1, K2 10.83023, K3 17.00708, and K4 51.95317. You can predict your Y, and that Y will be at X 2.5. At the moment, not necessary. You just find K1, K2, K3, K4 using this X and Y is enough. So you completed the whole table. So it looked very nice. That is the idea. So you complete the table. Any question, class? Yeah, class. Any question, class? I'm waiting for your questions, please. If you find any error in the table, please let us know. Of course, you can do exercise. Try the first Y first. You can try. You can try the first Y first. This one. You can try this Y first. But you must calculate K1, K2, K3, K4. Once you have this value, using Rangikota from X0, Y1, you create K1, K2, K3, K4, use this value, find your Y at X0.5. That is first attempt. After that, the rest is a repetition. A repetition meaning you perform the Y, the next Y, the next Y, the next Y for all the X in the interval 0.5. Yeah, class. Any question, class? Hello? Any question?
No question, sir.
Natasha, yeah. Others? Anyone else? Before I summarize and I close. today's lecture? Any question, class? Yeah.
No, sir.
Who is that? Who is that, please? Any question, class?
No, sir, we got no question, and I think you can summarize for today's
Yeah.
lecture, sir.
Yeah.
Thank you, sir.
Yeah. Before that, about the assignment, anyone missed the assignment? Anyone missed the assignment, online assignment? Hello? In this ME group, anyone missed the assignment? Yeah, Chia.
For me, no, sir. I did not miss.
Okay.
No.
Others. So,
Me too, sir.
oh,
Me also.
all done already.
Yeah.
Yeah.
Yes, sir.
How do you find?
Yes, sir. Yes, sir. Very challenging, sir.
Okay. So the time is very short or very long, Adam?
Just right, sir.
Just enough time, sir.
Okay. So you already knew the marks? Oh,
Yes.
all right. So those of you missed the assignment, we will have a replacement maybe week 8 or 9. This is week 7, right?
Yes, sir.
So after that, we will, after finish chapter 5, we will do the revision.
So share the solution for the assignment.
Assignment, I think most of you already got 40. If you want, we can give you the answer. Yeah, final answer. You mean final answer?
Solution.
Final answer only. No full solution. Full solution. Have you done assignment? Hello?
Yes, but
Who is
don't know the solution. I cannot solve all the solution.
Who is that? We.
Yes.
We, what happened? What is your marks? Assignment? Huh?
Mine.
Huh?
30 something. 30 something.
30 is over 40.
Yeah.
Oh. 5 question, right?
Yeah.
Each one 8 marks. We can discuss the problem. But it is better for us to do orally because it's not possible via written kind of thing. So I'm sorry, I cannot answer your question via email. So we can give you some, no, you have to ask question. Which one? Question 1, question 2, question 3, question 4, question 5. We can put up the question and we can discuss. And then, of course, you have to do. You have to practice. This is from chapter 1 and chapter 2, right? Am I right?
Yeah. Yes.
All right. So the information here is those of you missed. So we will do the replacement assignment via email or via online, as well as the quiz 1. So quiz 1 already finished, assignment 1 already finished. The next one is quiz 2. About the test, you have to ask the coordinator. Test 1, test 2. Okay. So I want to get the feedback from you on the assignment. So we summarize today's work, summary. Basically, now to answer the question whether the table is important or not, depend on how many iteration. If you do one iteration only, table not important. But if you do more than 4 iteration, this table is very nice. Because by looking at the table, we know whether all your output correct or not. So we can check your output as well as your K1, K2, K3, K4 values. So that's why the table is very important. So that is the answering why the table is important. So table is a very, we say, holistic way of presenting your output, input, as well as the K1 values. Okay, so now you can do comparative studies. So maybe we will repeat these methods again. Euler method, we already finished. Euler method is one of the very fundamental method, basic, which is what we call the pioneer as far as what you studied among these three methods. Euler method is the pioneer method, which involve one equation only, the derivative. Young's method, 2 steps, predictor and corrector. Of course, it's very hard to memorize the formula, but I think most of the time the formula will be given. So we want to know how you compute. It's a kind of a computational experiment. And then today we already finished this one, which is Rangikuta or Ranjkuta. So Ranjkuta actually is solve the first order differential equation, but this formula you must very familiar with this formula. Of course, it's very hard to memorize this formula. You got to practice class. Even we don't have much example. Maybe if time permits, in the near future, we can have 1 or 2 additional example. Because in this lecture, example 1 is very short. Example 2, the table is already given. So you just have to verify, then you will be satisfied. If the answer is different, please get back to us, because we can cross-check your answers with our answers. So the difference between Euler, Young's, fourth order Rangikuta is, fourth order Rangikuta is the most sophisticated method among these 3 methods. And then you can see the way they calculate the y output, yxi plus 1, using fourth order, the iteration method, k1, k2, k3, k4. You plug in yxi plus 1, and then using the previous yxi, you get the new xi as well as yi. So try to complete the table, and that is our final advice for you. Try to complete the table for this. Even 1.2, 1.3, 1.4 not written, but please, you go home and then try to work it out. Try to complete this table first, one by one, the second iteration, third iteration, fourth iteration, fifth iteration. So then you can see very clearly what is happening, especially for the output. This method you can use in the future for any of your projects, for your research, or any other extended work, or even for postgraduate studies. You can use this method. But there will be more advanced method than Rangikuta for postgraduate studies. Okay, class. So that's all for today. Any questions, final, before we stop? And please fill up the satisfaction poll via ulearn. I think today we cannot write the thing. So I don't know how you wrote just now, but my message here, you cannot see it, right? If I write any message here, you cannot read, right?
Yes, sir.
So
So you need to write in the meeting chat.
where it is? In the chat?
Meeting chat.
Yeah. Oh, you wrote here. So you need to look at the meeting chat. Yeah. Maybe you can do the solution on the paper first, then snap the picture with your phone, transfer to your computer and share the file. Which code solution you mean? Wang Kan? When can? Solution, which one?
Assignment.
Assignment, what is your marks?
I think I get half only.
Are you sure?
I forget, sir. So I forget.
Half only, 40 marks, right?
Yeah.
This one is, who is that? Answer with working, who is that? Is this today? Are you there? Roger?
Yes, sir. That
Oh.
one.
Can I take it as 0. Oh, I couldn't see yours in chat. Oh, it is in chat. Answer with working. Who is that? K can round up. Yeah. .5122. Which one? Farasha. Are you there, Farasha? Yeah, somebody asking question just now. Who is that?
Oh, sir, I think this one is the example one for our iteration, I think.
Okay,
The
okay.
first iteration.
Uh-huh.
I guess he asked, can we just round off to 4 decimal point instead of 5?
Oh, it's up to you. Yeah, it's up to you. Yeah.
And you told us 4 to 6 decimal point, yeah?
Yeah. Reasonably good one. Yeah. And then Mohammed Nur Hadi, the meeting chat is not working. So I don't know about that. Yong Wei Li. Shah, you say answer with working. What do you mean by that? Huh? Answer is, he mean for the assignment. Assignment, this is online assessment. It's a multiple choice. So you just, I think many of you got 40 over 40. We can give you the final solution. Can. Okay, class? Any more questions?
Sir?
Uh-huh.
Did Dr. Mohana tell you our test one for our EM2?
Not yet. You see
yeah.
in ULearn, got any message?
No, currently no, sir.
So for me, I didn't receive any message from him. Not yet. So far, not yet.
Okay, thank you, sir.
Yeah, you can find out from him.
Sir,
Yes, please.
is that okay if I create a WhatsApp group for us and then I invited you so that you can inform us and we don't need to like always check our ULearn?
Agree, sir.
No, this one is very difficult. Yeah, not easy. Any information, don't worry, I will inform you. Our lectures all on. Not necessary. Who's the young? Because it's already now 7th week already. So we left with another 5 more weeks only. So you just focus on the next few weeks about the, because it's too late already now. So you got to check ULearn because it's very important. Sorry about that. You got to check ULearn anything because verbally is not good. Black and white. So You just check in ULearn and then all the information are there. But it's very difficult for us to communicate with the other means. Even email is also not easy, yeah, because you're asking questions. We can give you like verbal question is okay, but write up, explain, and then sending. This is very difficult. Yeah, you can learn by yourself. Yeah, self studies is very important. Yeah. Okay. Assignment we will try. Yeah, the assignment because we already given you a good one, multiple choice, which is very good for you. But I don't think so. The test will be multiple choice. So we left with now quiz 2. So that is my second, the third task, week 8 or week 9, quiz 2. Okay, class. That's all for today. Yeah, one assignment only. Yes. Yes. That's one assignment only. I think morning class, I missed all the chat morning class. Yeah. So we have problem here. Yeah. Okay. So assignment only one. So one assignment, 2 quizzes, 2 tests, and then final exam is the EA. So we have to finish the 2 tests, test 1, test 2. You can refer to Dr. Mona, and then quiz 2 we will do maybe only on Laplace and Euler. Laplace and Euler. Because you already finished. Yes. Yes. Yeah, the last one, MCQ. Yeah, yes. Okay, so we stop here. Yeah, MCQ. Yeah. Please fill up the satisfaction poll.
Thank you, sir.
Okay, welcome. Okay.
Kelvin Lee Zhongxian.